So there, we're getting into the three basic interpretations of probability. There's classical, empirical, and subjective. We're going to look at classical first. That's what we're going to deal with most often. Classical probability uses sample spaces to determine the numerical probability that an event will happen. And the biggest thing that you should remember about classical probability is that all outcomes in the sample space are equally likely to occur. Okay? So here is your formula. P of E. What E means is any event. Okay? This is some event. Anything. Rolling a die. Flipping a coin. Guessing on a test. Okay? That's some event. N of E is the number of desired outcomes. Desired can be tricky because desired sometimes you think it's a good thing. Desired does not always mean a good thing. What's the probability that you contract Ebola right now? Not very high. It's definitely not desired, but it's what we're talking about. So if the event is getting Ebola, how many possible Ebola cases are there out there, and how many possible people are there? It's that's what we're talking about. I know that doesn't work perfectly for this case, but I want you to know that desired does not always mean that it's a good thing. Okay, it's just what we're talking about. And then the total number of possible outcomes. Okay, that's what S represents. So what is the probability of rolling a die once and getting a 5? Okay, so the event is getting a 5 when rolling a die. How many possible ways can you get a 5 when rolling a die? Just one, right? How many possible outcomes are there when you roll a die? There are 6. So your probability of rolling a die once and getting a 5 is 1/6. That easy, okay? Rounding rules for probabilities. They should be expressed as either a fraction or a decimal rounded to 2 or 3 decimal places. What I'm looking for is, for my class, you can do 2 the majority of the time. Okay. The only time you would go further than that is if, like, the probability was 0.000008. You could round it to 0.0008, right? You wouldn't need this 1. So you can go further out if they're all zeros before that, but if not, if it's 0.8753, round it to 2 decimals, so that'd be 0.88. Here we go. If a family has 3 children, find the probability that 2 of the 3 children are girls. So this goes back to our video from last night. What you need is you want your sample space. The sample space is very important with classical probability. So what's the probability that 2 of the 3 children are girls? Keep in mind, it says 2 of the 3, not at least 2 of the 3. So we're looking for exactly 2 of the 3 are girls. There's 3 boys, 1 girl, 1 girl. There's 2 girls, 2 girls, 2 girls. So the probability that 2 of the 3 are girls. So we have 3 different outcomes that have 2 girls. So the probability of having 2 of 3 children being girls would be 3, right? That's the desired part. That's what we were looking for. And how many possible ways can you have 3 children? 8 different ways. So the probability of having 2 of 3 children is 3/8. If you roll 2 dice at one time, what's the probability of getting a sum of 7 or 11? Again, we look at the sample space. So where is the sum 7 or 11 if you add them up? If we start looking on this diagonal right here, 6 plus 1, 5 plus 2, 4 plus 3, 3 plus 4, 2 plus 5, and 1 plus 6. Those all add up to 7. So we're looking at those, and where do they add up to? 11, 6 and 5, and 5 and 6. So how many of them are there? We got 6 here, 2 there, that's 8. How many total? So 8 goes on top. 8 is your desired. Okay, 6 plus 2. How many possible are there? There are 36 possible ways to roll 2 die at one time. And so you reduce that, that's 8 over 36, which reduces to 2/9. Now we're going to look at something called the complement of an event. So whatever that event is, whatever it is, it's E. The complement of it is denoted by E bar. So a bar above E. Okay, and that's red, the complement of E. It's the set of outcomes in the sample space that are not included for event E. So to find that, like back here, what would be the complement of getting the sum of 7 or 11? The complement would be anything that's not 7 or 11. So all of these numbers right here, let's see if it's going to let me write right now. All of these numbers and all of these numbers would be included in the complement. The probability of the two, the probability of E and the probability of the complement have to add up to 1. So therefore, if it's easier to find the complement, if it's easier to find the probability of E's complement, by subtracting it from 1, that will give you the probability of E. So this is a pretty important formula. Okay. So what would be the complement of, say, rolling a die and getting a 4, rolling the die and getting a 1, 2, 3, 5, or 6, anything that's not a 4. Probability of selecting a letter of the alphabet and getting a vowel, the complement of that would be getting a consonant, if you assume Y is a consonant. Selecting a month and getting a month that begins with J, the complement of that event would be picking a month and getting February, March, April, May, August, September, October, November, or December, a month that does not start with J. Selecting a day of the week and getting a weekday, selecting a day of the week and getting Saturday or Sunday. So these are all complements. Now, notice when you combine the two, you are getting everything. So selecting a day of the week and getting a weekday, so that's Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday or Sunday, that's every day in the week. If you roll a die and you get a 4, or you roll a die and get a 1, 2, 3, 5, or 6, that's every possibility. So the event and the complement of the event always have to include everything possible. Make sure you understand that. So sometimes it's easier that if you know the complement, or to find the complement, it's easier to use the initial probability. So for instance, if the probability that a person lives in an industrialized country of the world is 1/5, so 1/5 of the people in the world live in an industrialized country. What's the probability that a person does not live in an industrialized country? You could go out and you could try to count everything. You could try to count every person that does not live in an industrialized country. But if you already know how many people do live in an industrialized country, which is 1/5, the complement is people who do not live in it, it's way easier to just take 1 minus the complement. We are looking for not living in an industrialized country. The complement of that is living in an industrialized country, right? This is people who don't. This would be people who do. Those are the only two options. That's way easier to figure out this answer if you already know this. So you just take 1 minus 1/5. 4/5 do not live in an industrialized country. Again, if you put them together, 1/5 and 4/5, you should get everybody. Next up, we're going to look at empirical probability. Empirical probability is kind of the same concept, except we're looking at actual experiences. We're not looking at just We're not looking at things that are necessarily by chance. Okay? So it's still the same concept as the probability of some event is the frequency in that desired class. So whatever it is we're looking for, how many times did something fall into that class? And then this is divided by the sum of all the frequencies. So I'll kind of show you what we're talking about. We're going to use this example 4 or 5 times. We're going to look at different ways that you could set this up or different questions that could be asked. So we have a sample. We have 50 people, all right, and we took their blood type. So the reason this is empirical, one of the reasons is not all of them are equally likely, right? It's not a 25% chance for each having O, A, B, and AB blood. There's a different probability for each one. So from these 50 people, 21 of them had type O blood, 22 had type A blood, 5 had type B blood, and 2 had type AB blood. So if we're talking about those 50 people, right, this is kind of we did an experiment, okay? If we're looking at only those 50 people and we randomly pick one of them, what is the probability that that person has type O blood? So again, we're looking at the frequency in the desired class. The desired class is O blood. So what's the frequency? 21. What's the total sum of all the frequencies? 50. So our probability of picking O blood is 21 over 50. If that reduced, we would reduce it. If not, we leave it. One thing I want to point out, I should have earlier, but the way that this is written, the format of it, it's always P, which represents the probability of something. Now, this sometimes has to be written out. It's a few words long. Okay, sometimes it's just, in this case, O is enough. We know we're looking for type O. So whatever goes in parentheses here is that's the probability of this event. Okay. What's the probability that a person has type A or type B blood? We're looking for one or the other. So we're going to be looking for actually 2 of them, these 2, 22 and 5. We add those up. We got 27. The total frequency is still 50. So the probability of A or B would be 27. The probability that a person has neither A nor O, you could do this one of 2 ways. You could find A or O and take the complement of it. Or you could just eliminate A and O. So we're not looking for A, we're not looking for O. What's everything else that's left? Type B and type AB. So 5 plus 2, you got 7. There's still 50 total. What about a person that does not have type AB blood? Well, we could add all these up, right? We're looking for not AB, so we could technically just cross this out and add up everything else. 22, 5, 21. And that wouldn't be too hard for this. But what if we were talking about an experiment where we had 100 different types, 100 different possibilities? Would we really want to add up all the other 99 options? You could. That'd be fine. It would just take a little bit more time. And so it's up to you how much time you want to use on this. But instead of adding up everything else, why don't we just look? Erase that real quick. Okay. Why don't we just find out what is the probability of having AB blood? The probability of having AB blood would be 2/50. So the probability that a person does not have AB blood would be the complement, everything else. And it's easier. I don't want this. to just taking the complement of it. So the probability of not having AB would be the probability of having AB subtracted from 1, because 1 represents 100%. So 1 minus 2/50ths is 48/50ths, which reduces to 24/25ths. And finally, subjective probability. Subjective probability uses a probability value that's based on an educated guess. Okay? Subjective probability is the least accurate. Okay? Because, like I said, it's an educated guess. Sometimes it has opinions and definitely inexact information. And the perfect example of that is right there. Weather forecasting. Okay? Yes, they use data, they use models. It is an educated guess, and they are right actually a pretty good percentage of the time when you consider what they're trying to predict. But they are far from accurate all the time. That's subjective probability. So when they say the probability, the chance that it'll rain tomorrow is 60%, it's completely subjective. Okay, they are using data, they are using their opinion, but the fact of the matter is we know it's subjective because you can look at 3 different forecasts and see 3 different percentages. KFYR may be saying 60%, the Weather Channel says 40%, and KXMB says 100% or 90%. It all depends on, it's got a lot of opinion in it. Okay, that's it for this section. So like I said, you will have an assignment tomorrow, Friday, and you will have another one on Monday, which will all go on the same assignment. I did pretty good. This one wasn't too much longer than the last one, so you're welcome. I'll take it. Have a good weekend, and I will see you on Wednesday. You can expect there should be a new video on Monday night.